Hello everybody, this is my group presentation talking about how acetyl CoA is generated from pyruvate after pyruvate is made from the glycolysis process. And I'm going to apologize in advance for my mispronunciation of some of the words in this presentation. I know I'm not going to say them correctly. So the first step kind of in this process or cycle is the transportation of the pyruvate after glycolysis, which takes place in the cytoplasm of the cell. That pyruvate needs to be transported because the citric acid cycle takes place in the mitochondria. So after glycolysis, the pyruvate must be transported to the mitochondria, and once in that mitochondria matrix, the pyruvate is oxidatively decarboxylated by the pyruvate dehydrogenase complex to form acetyl CoA. So I kind of just added a picture that technically this shows all three of the processes, starting with the pyruvate in the cytoplasm needs to get transported to the mitochondria. End product is acetyl CoA, and then we'll discuss all the different coenzymes and such needed to get to that final product. So enzymes and coenzymes of the pyruvate dehydrogenase complex for the synthesis. Synthesizing acetyl CoA from pyruvate takes 3 enzymes and 5 coenzymes. So these 3 enzymes include pyruvate dehydrogenase, dihydrolipoyl transacetylase, and dihydrolipoyl dehydrogenase. And then the 5 coenzymes include thiamine pyrophosphate, which is TPP, and then lipoic acid, and flavin adenine dinucleotide. And those are all catalytic coenzymes. The remaining 2, which is CoA and nicotinamide adenine dinucleotide, NAD, those are both stoichiometric coenzymes. And so this synthesis has technically 3 different steps in the actual conversion of pyruvate to the acetyl CoA. Those 3 different steps are the decarboxylation, the oxidation, and then the transfer to CoA. And so I just included kind of just another picture of the same one before. It just kind of looks a little bit different. And then at the top it kind of talks about what that pyruvate dehydrogenase complex is, saying that it's a multi-enzyme complex containing 3 enzymes, 5 coenzymes, those ones I just mentioned before. And then at the bottom we have the 3 different steps that it talks about below, and then yeah. So we're going to move on to the first step, which is the decarboxylation step. And so in this, the pyruvate combines with the ionized form of the TPP and is then decarboxylated to yield hydroxyethyl, TPP, and CO2. And so the rate limiting step in the synthesis of acetyl CoA is catalyzed by the pyruvate dehydrogenase complex, E1, of the multi-enzyme complex. And then TPP is the coenzyme of the pyruvate dehydrogenase component. And that's in this specific step. So over here, it's basically another picture of the whole thing again, just kind of different placement of things. And so down here we kind of see pyruvate dehydrogenase complex, and then I don't know if you can see it says E1, E2, and E3 below. And then right here, that's the TPP, so that would be the coenzyme in this specific step. And the next step is the oxidation step. And so in this, the hydroxyethyl group attaches to the TPP is oxidized to form an acetyl group while simultaneously being transferred to lipoamide, which is a derivative of lipoic acid. And this results in the formation of an energy-rich thioester bond. The disulfide bond of lipoamide is reduced to its disulfhydryl form in this reaction. And then this reaction, which is also catalyzed by the pyruvate dehydrogenase component E1, is going to yield acetyl lipoamide. And then I kind of, another picture, once again, it kind of shows all the steps, but this one's kind of, I think, more focused in on the oxidation step. And so up above it's got the numbers, and then below kind of explains what's happening in each step. And so I thought it was just kind of a nice picture to explain what's going on. Sorry if it's dark. And then the last step is the transfer of acetyl CoA. So the acetyl group is transferred from the acetyl lipoamide to CoA to form acetyl CoA. And the dihydroyl lipoyl transacetylase E2 catalyzes this reaction, and the energy-rich thioester bond is preserved as the acetyl group is transferred to CoA. And acetyl-CoA, which is the fuel in the citric acid cycle, has now been successfully generated from the pyruvate molecule. And over here, I just kind of put what the acetyl-CoA molecule actually looks like. And then this necessary fourth step that is needed for the cycle to basically take place again, the dihydrolipoamide must be oxidized to lipoamide, and then in this fourth step, the oxidized form of lipoamide is now regenerated by dihydrolipoyl dehydrogenase in the E3, and then 2 electrons are transferred to an FAD prosthetic group of the enzyme, and then to NAD+. And so then another pyruvate molecule will be able to bind and start the whole synthesis process over to form more acetyl CoA. All right, thank you.